up the computations sometimes in Calculus 1, we use these basic identities, especially when we're doing like parts of questions, including properties like a plus b squared or a minus b squared. A and b could be numbers or other quantities, even functions. So what is a plus b squared? Well, you would like to say that that is just a squared plus b squared, but we know that that's not true. And the way that you can find it is just basically write what this is all about. This just means a plus b times a plus b. And then you FOIL, and you get a squared plus ab plus ba plus b squared. And now these two terms are the same, so you can say this is a squared plus 2ab plus b squared. And so what do we mean by identity? By identity, we mean that we skip the intermediate steps, and every time we see this, we know that this is equal to a squared plus 2ab plus b squared. Now, similarly, you can compute this one, the a minus b squared. I will skip the intermediate steps and go directly to the end. So this is equal to a squared minus 2ab plus b squared. Now, this is another one, a minus b times a plus b. This shows up a lot when you multiply with the conjugate, as it is called. So let's go ahead and actually do the computation here, see what happens. Here you get a squared minus ba plus ab plus, minus b squared. And now what happens is the minus ba and the plus ab cancel out. And what you're left with is a squared minus b squared. So the identity is basically when you have a minus b times a plus b, two conjugates multiplied together, you get a squared minus b squared. Sometimes we use it the other way around. When you have a squared minus b squared, you replace it by this one. This is factoring. This is just basically doing the computation. Another interesting one is a plus b and the whole thing cubed, and then I'm going to skip the multiplication. But what you get is a cubed plus 3a squared b plus 3ab squared plus b cubed. A nice way to think about it is 1, 3, 3, 1. The powers of a going down, a to the third, a to the second, a to the first, and no a. And the powers of b go up, no b, b to the first, b squared, and b cubed. Similarly, with the a minus b cubed, the easiest way to do it is remember this guy. It has the same terms as the one on top. And then the signs here alternate to plus, minus, plus, minus. Another one is a cubed minus b cubed. That doesn't show up many times, but you may see it, especially in the factored form. This is equal to a minus b times a squared plus ab plus b squared. Okay, so this is the difference of two cubes. The sum of two cubes is a plus b, a squared minus ab plus b squared. And again, you can verify these by, let's say, multiplying here and expanding it, and you'll see that these are the only ones that survive. Same thing with that one. So it makes sense to learn those identities. By identities, I mean that a plus b squared ultimately gives you this. That will speed things up, and you will be able to follow some professor that just doesn't bother going over the details.